Hello, everybody. I hope everybody's doing good today. We are in the middle of the managing our waste section, and we need to do something. We need to do those 7 R's, in my humble opinion. First, we need to rethink how we do things. And one of the main ways we do things with our waste is we basically just bury it in a landfill. And I talked about last presentation about how we got to work on composting and turning our organic waste into compost. But it's hard to collect all that stuff. It's just mixed in there with all of our rigmarole, and it just goes into the landfill. But believe it or not, that landfill, that organic waste, does get used up. It gets eaten up by different bacteria through its life cycle and releases what's called methane, and that could be that's basically our natural gas. All right, that's where it comes from. So, in a sense, we could capture all that stuff, and that's called landfill gas. And I really like this innovation, and it's really has turned into a pretty profitable adventure for the waste management and the companies that implement this. They don't only produce electricity for this; they also run some of their trucks on natural gas on their for their fleet. So they use a lot of this stuff, and it makes sense. And that typical landfill will last, depends on the size. Of course, you got to do the math, but typically about 50 years. So is it renewable? I'd say yes because we're using current trash or current organic waste. But it does have a life shelf, and then we got to build a new landfill and collect that and get that organic waste out of there, the methane released from that. And please note that remember, this is also used on farms. A lot of farms will do this one, or where we have those confined animal feedlots. We'll make a methane digester, just like over the landfill, and collect all that poop and put it in there, and the same bacteria breaks down that poop. So we also are doing this on a farm scale, but the problem is it's just too diffused. It's spread out, and it's not concentrated like that nice little chunk of coal we can get out. All right, we got to keep on collecting it instead of having it build up over those millions of years. So let's check out this little video here about landfill gas made by Waste Management. So we do this in America a lot, and Waste Management is probably one of the best companies that are on the cutting edge of this type of process.
As communities grow, the demand for renewable energy is increasing. Waste management is helping to fill this need by using waste from homes and businesses across North America to generate electricity. Currently, Waste Management produces enough electricity to power more than 400,000 homes through a source of renewable energy called landfill gas. Today's modern landfill uses advanced engineering to dispose of waste and protect the environment. At more than 80 waste management sites, renewable energy plants produce electricity using naturally occurring landfill gas. The process begins when waste is collected. One person produces an average of 4.5 pounds of trash every day. While some waste can be recycled, a portion is taken to a landfill for safe
Unless
disposal.
you're like that one girl who
Once inside the landfill, the
created
waste
a
decomposes
mason
to
jar over
produce
2 years.
methane. Landfill gas, comprised of about 50%
And she
methane, is
composted a lot of
purified
organic
using
waste,
an
didn't she?
underground network of pipes and wells. From this network, the gas is drawn to a renewable energy facility's compression system, where the gas is dewatered, pressurized, and filtered to make it clean. When landfill gas enters this system, it first passes through a filter, which removes any large pieces of debris and some liquids that may have become mixed with the gas. After initial filtering, it enters a compressor, which raises its pressure until it's high enough for the gas to be used as a fuel. During compression, the temperature of the gas rises and must be cooled down by an aftercooler. Inside the aftercooler, the temperature of the gas is lowered, which allows for any remaining moisture to be condensed. The gas is then filtered a second time
This is how
to
we take it
eliminate
out of the
the
ground
condensed
too,
moisture.
or we um, pipe
At
it
this
out of the,
stage,
have
the
a
gas is
regular gas
refitted to
well.
prevent any further
Have
condensation
to do the same
and is
stuff.
ready to be used as a renewable energy
It's just
fuel.
there's a lot more of that
The whole process from
gas
start
in
to
a
finish
regular
takes seconds.
well.
Waste management renewable energy facilities use either an engine or a turbine to generate power. Both follow the same basic
Same as a
principle
coal
to produce
plant,
electricity.
wind
An
turbine.
engine that runs on
They're
landfill
turning some
gas
magnets
really
around
is
some
a bit
copper
different
wires.
from a car engine. It's equipped with pistons, an air filter, exhaust, radiators, and even batteries. Landfill gas enters the engine and is combusted, causing the
Just burn
pistons
it
to spin a drive shaft. The drive shaft is connected to a generator, which
with
converts the
some
power into
magnets going
electricity.
around some copper wires.
The electricity is then sent to state-of-the-art control systems, which ensure that the plant is meeting the needs of the utility. Control systems direct electricity to transformers located on site, which either raise or lower the voltage. Low voltage electricity is used to power equipment within the renewable energy facility, while high voltage electricity is exported to the utility grid to supply energy for communities and businesses. With new plants appearing every year at waste management landfills, the amount of renewable energy we provide is positioned to grow for years to come. Most people forget about their trash as soon as it leaves the curb. At Waste Management, our goal is to be the industry leader in finding innovative uses for waste, whether it's through recycling, composting, or creating renewable energy. Waste Management is committed to using trash as a resource to help communities meet their energy needs.
Yeah, I'll have to give it to Waste Management. They do, they've had some problems in the past or whatever. Every company has their mistakes and such. Um, but I think they have done a good job. And the way they're doing this renewable energy, doing that landfill gas, is something to behold. And it is really just the same process of getting that gas out of a well that's been there for, that gas has been there for millions of years. This is just recent new gas, right? It's renewable. It's our waste or organic waste that we're not composting, and just it will go out into the atmosphere no matter what half the time. So um, it's a good way to capture some energy. All right, we're thinking more efficiently. All right, and it's one of my favorite ways to do it. And I do like natural gas. It definitely, there's no carbon dioxide when you burn it and stuff like that. And I think that we're already throwing this stuff away. We need to rethink our things, and I think this is one way to rethink it, is being able to go over after that landfill gas. All right, because we've been using these sanitary landfills as our main disposal method for I don't know how long. I think even in the Bible, when Jesus is talking about hell, he's actually talking about the garbage, the landfill outside of Jerusalem or wherever. I'm pretty sure that's how the story goes. I'm not too much of a, I shouldn't bring that up, but I think that's what he talks about. Okay. Uh, so sanitary landfills bury waste in the ground and just pile it up in large mounds engineered to prevent waste from contaminating the environment. So it's tried to be designed to not leach out into the area. So they take it and they layer it on the municipality. We'll see a diagram of it in the next slide here. Municipalities, landfills must adhere to standards set by the EPA under the Resource Conservation and Recovery Act. So, like I said before, the United States federal government lays out the guidelines, and every municipality must fall within inside those guidelines. The municipality, however, get to pick out who gets to pick up the trash, where they put it, just as long as that lead that will kill us all is not getting into the environment and stuff like that. So there's certain designs, principles that they must adhere to, but the municipality decides where the location should be, whether it should be in the municipality or actually ship it out to somebody else. All right. So all we're doing in these sanitary landfills is the waste is placed in a landfill, partially decomposed by the bacteria and compressed under its own weight. So we just pile up all the stuff down here in the bottom, and slowly but surely, as we add in the garbage, we put layers of soil. So here's little blocks of garbage right here. And we put little layers of soil just to block them in. All right. And down here, we got some drainage pipes, all right, for when the rain comes down. We can suck that leachate water out, all right, and put it in there. On the bottom here, there's also, I forgot to tell you about the liner on the very bottom, all right. And we put in pipes and some drainage, and then uh, just some more drainage kind of stuff, and then we start putting it in the garbage. All right, and we just pile it up, and we get doming up. All right, and what happens instead of, uh, we have all these different pipes getting the water out. We have these other pipes with the natural gas going down and drilling into here and tapping into the gas that's released by the anaerobic bacteria, the different bacteria that's eating these things. Okay, and we just take it out and burn it. The liners in collection system prevents the liquid leachate from escaping from the nearby groundwater. So these liners down here on the bottom are very important. But there is probably I have no way to repair those liners if they do rip. All right. So once there's a leak, there's always going to be a leak. I don't know how we're going to get back down there and fix that stuff. So landfills must be located, it's one of the requirements, must be located away from different wetlands and earthquake-prone faults, and at least 6 meters above the water table to prevent some of that leaching. So there's different guidelines that the federal government, we generally consider what is safe, and spread that across the nation. Closed landfills are converted into public parks after they're all done, such as Fresh Kills Park in New York City. So we just bury it all up and then put some soil in there and plant some grasses or trees or whatever. We turn it into a park, or we turn it into a mall. Century 3 Mall. I don't know if you guys have ever heard of that mall. It's kind of probably closed down by now. It was never doing too good, but that was built on an old slag heap. From our old coal. We used to take our coal. It was all hot, kind of lava kind of looking stuff. And we used to just throw it down there, and it hardened up, and we built that mall out there. And you can still go out there at 2 Century 3 and see the hillside all made out of slag. Interesting how we do that. But hey, behind is the best purpose. Out of sight, out of mind. We could turn this into this. All right, and I wonder what the archaeologists are going to think when they find all this thing, 100,000 years from now. What are they going to think when they find this stuff? Oh my goodness. We can also burn all our trash. Like I said, is becoming more and more popular, although there are some more toxins and regulations that we need to mitigate for when we're just throwing all that trash in there, because each one has its different, each particle has its different toxicity level. All right. And it's controlled by a process in which garbage is burned at a very high temperature. We got to really incinerate this stuff. And reduces the weight of the waste up to 85%. So the volume up to 95%. So when we're all said and done, the ash reduces just like a fire. You see the big logs on a fire turn into all this small little ash. That's what happens. Now we have less to throw away. But did those particles go anywhere? No, they're still with us here on the Earth. They just went into the atmosphere in the form of gas and heat. All right. So the emissions of incinerators must pass through what are called scrubbers, all right, because we have all these different toxins in there. Okay, so we just take the solid waste to be delivered, put it in there just like the coal. We burn it, all right, and it heats some water, which makes some steam to turn a turbine, which turns a generator. Inside that generator are the magnets and the copper wires that give us the electricity. All right. But as that, instead of the smokestack going directly out, it goes into what's called scrubbers. And the coal plants do this as well. All right. These scrubbers were implemented back in the 70s to help with the acid rain, and they take out a lot of the toxins. All right. And it goes, that smoke goes out through here in that water, goes out through here and gets cleaned up in the scrubbers. All right. And all the different heavy particles, all the ash, and things that don't, would float up in the air. When you see that fire, you see that ash floating in the air. Well, there's going to be some of that ash floating when we're burning the garbage as well. All right. So that stuff gets caught in what's called the bag house. And this is a tough job emptying out the bag house stuff. I'm telling you what, I've seen someone have to do this in a coal fire plant. And boy, is that a job and a half. All right. I can imagine what it's like with all this other extra debris. All right. And then the water just cooled down just like a regular power plant. So it works just the same as a coal fire plant or a nuclear plant. Water's boiled and heated, and then toxins are segregated out, right? And water's cooled down and put back into the system. It's really the same thing. It's all about the magnets going around these copper wires. How can we get these magnets around the copper wires? We can do it by this, or we can put a windmill up there too, right? Or some water in a dam. Recycling is the next thing we really need to tackle here in the United States um, to relieve the impact on our landfills. All right, so steel, aluminum, copper, and other metals are abundant enough in some landfills to make salvage operations profitable. So there are some areas where you can just go and make some money. That's what my one buddy does. All right, he doesn't go directly to the landfills. He goes to the building itself. All right, right before it's supposed to be demolished. I remember he took me down to the old Three Rivers Stadium, and I helped him out on a job one time. Yeah, it was pretty fun, man. Got to see that place before it got exploded. You guys don't even probably remember Three Rivers Stadium. Also, that organic waste from landfills could be mined and composted. I don't know why would anybody want to do that. We might as well just make it into a landfill gas system. All right, I think that's a little bit too much effort. The energy rate of return would not be too much. All the landfill waste could also have been incinerated into waste, so we can dig it back up and burn it, right? And relieve some of the stress that way if we wanted to. So all three of these can actually be done. All right, it's not too late. Industrial solid waste includes, so that's the municipal, that's our households and some of our businesses and things like that. Then there's also industrial solid waste, which includes the waste from our factories and mining activities, agriculture, and all the good old stuff that we don't see, out of sight, out of mind. It said that a wedding ring size of gold creates one Olympic-sized pool of toxic soup to get that gold out of there to put in that ring. Unbelievable. Methods and strategies in industrial waste disposal are similar to those of municipal waste, but we have more control over it. All right, so there's what's called point source pollution and non-point source pollution. So point source pollution, if you just use your critical thinking skills and think about the words, we can directly see where that pollution is coming from, and we can regulate that. We can say that factory right there is the one that's polluting the water, so they're going to have to do this, this, and this to keep that out of the water. All right, so that's nice and easy. But there's also what's called non-point point source pollution. That's spread over a large swath. We don't know exactly who is responsible for the pollution. Which car leaked oil on the road that put the water system over the edge? Which household fertilizing their lawn caused that algae bloom in Raccoon Creek? All right, which farm had too many cows on it that caused all that extra nitrogen and ruined the ripen area of the streams. All right, so the non-point source pollution is harder to control, right? As in industrial solid waste is more of a point source solution, so we can pinpoint who's making it. And we like to use, or I like to use, the polluter pay principle, meaning you pollute, you pay, right? And that's all part of the cost. And of course, that cost will be put back on to the consumers, but that's part of that product, right? So federal regulations regulate municipal solid waste. So the EPA is in charge of that. We as a nation decide generally what is considered safe of levels being emitted via factory waste into the atmosphere or into the ground or what have you. So we don't go killing everybody. State and local governments regulate industrial solid waste, with regulations generally being less stricter than municipal solid waste. So it comes down to the municipal and the state to enforce the federal guidelines, and they can put in their own little guidelines if they want to be stricter, if they want to. Having said that, typically the manufacturers and industrialists have less guidelines because they're more, I hate to put this, they're more precise on what they have to do. All right, but they kind of have a little bit of leeway in amounts of pollution allowed to be put out than regular you and I have to do that, and that's to help the economy. They say, okay, and you take it as you will, okay. Industry bases most of its practices on economic efficiency instead of physical efficiency, where less waste is produced per product. So they want to be able to, it's a business, and here in the United States, the business must maximize shareholder profits. Okay, that's their number one goal. It's not taking care of the environment, folks. It's maximizing profits. So if it's more profitable for them to pollute, they will choose the pollution over anything else. It's just the way it is. Okay. Um, Even if it's a more wasteful, you know, a more wasteful thing for the environment in the long run. Okay. Because of this problem of industry always trying to maximize their profits, uh, and kind of not looking at the environmental side. So, ecological economists think of everything as a system, all right? And there's also what's called industrial ecology, all right? And that is, since everything's in a system, the dung beetle eats our poop, right? And we eat the plants, and the plants, in a sense, all one big old system. But there's also a system if you look around in the business world. All right, so, and this is called industrial ecology. It integrates the principles from engineering, chemistry, ecology, economy, economics, and mixes both physical and economic efficiencies together. All right, and the goal is to function more like an ecological system than a business. All right, you want to be able to work together. So my waste from my byproduct of my car manufacturing plant can actually go and be worked in and used in a textile plant, and then their waste can be sent to a pig manufacturer, and they can eat leftover fibers. Believe it or not, that's the way it works. This involves making several changes to industry processes, though. All right. So, and we're going to watch a video after this, and we'll see how this works out in Germany. All right. So hopefully I'll be able to find that video real quick for us. So let's do this one last slide and watch that video and get this thing over with here. So a life cycle analysis looks at the way to make up any part of generating a product. And this is some of the stuff we study in that sustainability minor here at Robert Morris. We study the life cycle process of a widget, all right, the throughput, right, and how to make that throughput the most efficiently, not only for the cost of the business, but also for the environment. All right, so it's not only about maximizing cost, it's also about maximizing social cost or minimizing social cost, I should say. All right, so waste products are one of the processes that are incorporated into other processes. So environmental harm products are eliminated from the industry process. So they just totally get rid of stuff that's going to really, really harm the environment. All right, that's already taken off the table, and they accept the higher cost, as in price, for that product that's made more sustainably. Okay, because in the long run, they will actually gain money. Believe it or not, if you do the break even. Design changes are made to increase durability, recyclability, and reusability. All right, so we actually have a system here in the computer world called planned obsolescence. So if you're building something today, you got to remember that in 4 years it's going to be obsolete. So that computer and the hard drive and everything in there is not going to be being used anymore. All right, that operating system is going to be obsolete in 4 years. So you need to be able to plan for that, be able to add on to your operating system, or just plan for it to be super duper or what have you. All right, because we have a disposable society. We need to change that. All right. Let me see if I can find that one video for you real fast about industrial ecology. Let me see. There's a good place in Denmark that we are in Germany that really does that, but I think it's going to be too long of a video. So let's watch this one right here. Where are you, my friends? Okay, so industrial ecology, we are trying to link everything together. So your neighbor that's actually making something in your factory plant or whatever, in your working plant, can actually use some of the stuff that you left over, right? So you all work together and becomes a interwoven um, teamwork of different companies. Right? And this is also called the circular economy. All right. So let's take a look at this little video about industrial ecology. That was exciting.
Hello there. Let us talk about our
And then
material
we study
and
this stuff in that sustainable
and what we
development
can do about it.
course.
As
How
a
we do this.
society, we use heaps of materials all the time. Concrete and steel for buildings and infrastructure, fossil fuels for energy supply and plastic products, biomass for fuel production, metals and minerals for many other products. The average Australian has a material footprint of about 40 tons per year, 40. That's 4 times larger than the global average of 10 tons per person per year. All of these material flows create environmental impacts, and many of our products become waste. On average, we recycle only about 1/3 of our waste. In this module, you will learn about 2 concepts that try to minimize our waste footprint: industrial ecology and circular economy. So what do they mean? In industrial ecology, we try to learn from natural ecosystems on how to deal with waste flows. After all, these natural systems have done it for many millions and sometimes even billions of years. Understanding how they do this can help us design more sustainable industrial systems, where the waste of one industry becomes a resource for another industry. And then we have circular economy. Circular economy is a very similar concept, but focused more on products rather than industries. The idea is to keep products, components, and materials circulating in use for as long as possible through long-lasting design, repair, reuse, remanufacturing, and recycling. The ultimate aim is to minimize the amount of resources we consume and the waste we generate. So, as you can see, this is much, much more than just recycling waste. In fact, recycling is actually not the preferred option of how to deal with waste, because it needs energy and resources on its own. Rather, we are talking about a completely new model of industrial production, which involves designing products so they don't become waste in the first place, so they last longer, so they can be repaired and upgraded, so they can be reused or resold, and so that materials can be used in remanufacturing. Both these concepts, industrial ecology and circular economy, are aiming to achieve what we call a restorative process, where materials and products can be reused many times. A good example of such a transformation is the take-up of prefabrication in the construction sector with machining off-site. This allows for almost zero waste production of building components, easy retrieval of materials and components, and building elements that are easy to reuse when the building is being demolished.
So he's talking about prefab houses. So we'll build you a wall and ship it to you and you put it up.
And we want you, as the engineers of the future, to become part of that. Thank you.
All right, you don't have to be an engineer of the future to participate in this kind of stuff. You can be an accountant, a financial planner, a nurse, or what have you. All right, because we got to start thinking about how we're going to minimize our waste. And that's what I liked about that. I'm doing shameless plugs for this sustainability minor, because it applies to every facet, whether you're going to be working in an industry, trying to do some industrial ecology, or if you're working on a product, or if you're saving lives as a nurse, because there's a lot of intertwining waste streams inside that have a lot of bio waste and stuff like that inside the hospitals and things like that. So we need innovative minds that think a new way. We need to really rethink our waste stream and realizing that there is no way here in the world that our waste in my business is also someone else's product. All right. All right, so let's call it quits for this lecture. If you guys have any questions or problems, please don't hesitate to drop me an email or a text or what have you. I'm around. My kids seem to be having fun doing their schoolwork here at home. I'm kind of having fun doing these presentations too. So I think everything's working out. So stay safe out there, stay confined, and listen to the scientists. All right, and be good. Bye-bye.